We had trouble Thursday night on this pulley design here on page, I believe, 4-1 of my handouts. I forget where I got this design. I like to think it came out of the machinery or machinist handbook I bought back in the 80s, and is and should show an accurate way to design or dimension pulleys, with the angle of the V being specific rather than the distance. Anyway, let me start off making this thing. As always, I got, well, not as always. Now I'm trying to get used to dynamic input, so I got that turned on. Polar tracking is set for 90. I got burned having it set for 45 for 3D work. I'm going to keep object snap tracking on just to see if I can use it. Don't know if it's beneficial in 3D work or not. I got object snaps on and set to my 5 favorite. Freeze the screen here and make note of them if you want. We need to get horizontal lines and vertical lines so that we can develop this profile of this pulley design shown in cross-hatching in order to revolve it into a full pulley, or revolve it into 270 degrees to get a full section view of the pulley. I'm sorry, half section of the pulley. Getting most of the horizontal lines is easy because the diameters are here, but you don't know the diameter of this hidden line there. It's got to be subtracted from the top. Looks like that 9/16 is a little off. I'll pretend I didn't see that. Let's create the circles, and the outer one I can simply offset 9/16 of an inch to get the bottom of the V. We'll go to the circle command. Circle center radius is the top icon on the circle flyout menu. I'll click it. I'll pick a random point. I'll say I want D for diameter. Click D, or hit the diameter option, or type D, and that would be 3. Enter. I'll zoom in a bit, rolling the IntelliMouse wheel. Got another one here, 1 1/16. I'll take advantage of the center diameter icon rather than having to invoke the diameter option. And that is a 1 1/16. AutoCAD will recognize fractions, so you don't have to look at a chart or pull your calculator up to get the decimal. See, these two are the hole for the shaft of the pulley is simply a 1/2 inch. We'll click this diameter, hover around, snap 0.5, easy as 1/2. Now again, the bottom here is 9/16 less than the outer, which is 3. So I should be able to offset this by 9/16 inward. Go to the offset command, type 9/16 rather than figure the decimal. Select the outer, click it in. So there's our 1, 2, 3, 4, 5 lines, including a center line that will needed to develop this profile, and of course the center line. The mission is not to develop the right side view. If this is a good choice for the right side view, it looks more like a front view because it shows detail. But anyway, our mission is to develop this crosshatch perimeter with a notice that, hey, the axis of rotation is I believe 1/4 inch below the profile. So let's draw some lines for the horizontal lines of our sheet of graph paper, so to speak, and later we'll connect the dots to develop the profile to revolve. We got the top one there. I'll launch the copy command. I'll snap at endpoint and machine gun down at each quadrant and at the center point. Okay, so there's our sheet of our music sheet showing the horizontal lines. Let's develop a vertical line. We'll pick a random point, and probably right there. I'm going to take advantage of 90-degree polar tracking. Okay, we can offset or copy that randomly placed vertical line by 3/4. I'll click offset 0.75 or 3/4. Whoop, type comma, keep doing that. 3, there we go. 0.75, enter. Select the vertical line, click to the left. Now, how do we get these nudges here? It says there's 1/2 inch between them. Well, doing a little arithmetic will show you that the right and left lines here could be offset inward, toward the space between them by 1/8 of an inch. But let me show you another way to do it that might, avoids the hassle of doing arithmetic. I'll draw a line like there. 1/2 inch is the space between the top of the V. Let's see if I can zoom in. 1/2 inch from the corner of the left side to the corner of the right side of the V. So I'll draw a 1/2 inch line and place it at the center of this guideline I just drew. 0.5. Enter, enter. There's my 1/2 inch line. I'll move it so that it is centered on this guideline. Now, when I click on that, it's got, there we go. It's got endpoints right where we want to start the diagonal lines for the V's. Now, if there's 36 degrees between the two lines of the V, then each one is off of vertical by 1/2 of that, which is 18 degrees. So I can draw a vertical line and rotate it by 18 degrees in the right direction and use that to mirror to the other. So rather than rigging polar tracking to an additional angle, I'll launch the line command. I'll O-snap at that endpoint I just drew on guidelines, come down vertically in excess, enter. Now I'll rotate it positive 18 degrees to swing it counterclockwise for the left side of the V. There's the rotate command. I'll click it, I'll hit enter, I'll pick the top, and I'll type 18 degrees. The other one's even easier. I'll drop down and use my old, by the way, I'm on the 3D modeling workspace. This is a level 2 class assignment we did last night. Drop down, I'll do the old 2D mirror command or icon. Select it, hit enter, O-snap at the middle of this guideline, and polar track straight up or down and click enter. I forgot. I should have drawn the guideline straight down. Not a problem. I'll stretch, or I'll, whoa. Messed up the mirror, always something. Mirror, click, enter, there, and enter for no. I need to get these lines down to the top of the pulley. So I'll launch the move icon, select these two diagonal lines, enter, and grab them from that construction line and slide them back down to where I should have drawn them in the first place. Click. Got no need for this guideline, so I'll delete it before it causes confusion. I ought to trim up and clean this a little bit. Trim. On 2022, everything is a cutting edge by default. Earlier than 2022, certainly 2020, you got to hit enter to get everything to be a cutting edge. So again, 2022 has everything as a cutting edge. Also, 2022 has got uses the trim command for erase. You don't have to invoke an option to toggle the trim command into erase. There we go. That looks good for our V. Looking good so far. Let's see, this hub here sticks out 3/8 of an inch, so I'll offset this line leftward 3/8. Click offset, type 3/8 or 0.375, enter. Select that vertical line and go click over. Okay, we got our profile already, with the exception of all the radii. There's 2 radii to apply. And remember here at the bottom of the, right, I'm sorry, the hidden line there, right there, that's a 0 radius. So I don't know whether to take advantage of the polyline command. Oh, and these are 0 radius too. I think I better fill it each corner individually. 1, 2, 3, 4, 5. Yeah. Fill it 5 corners individually and change the radius setting and fill it the 6th one here. Right? Yeah. Leaving these 2 corners at the bottom at 0 radius. By the way, I'll trim and narrow down the aesthetics a bit. E for erase, sorry. U for enter. I'll trim away that line and erase these other 3. All right, I'll grip edit this line and pull it down to the intersection. One of my 5 favorite O snaps. There's our basic profile. We still got to do the filleting. Zoom in on it. By the way, we'll trace this intersection to intersect. Whoa, I did it again. I hate it when I do that. All right, I got to stretch them down. The hub is in this perimeter, as I did last night. I put it a little too high. Let's see, where's stretch? I'll stretch them down. And I'll grip edit. Okay, I think we're good to go. I'll TR trim to lose that and that and that. So there, this open space is now our profile that we show here on the handout in crosshatch. I forget which ANSI number this is and what material it represents. I used to have a few of them memorized. Anyway, most of the fillets are a 32nd of an inch, just enough to keep from cutting people that are handling this, I think. So I'll launch the fillet command. I'll immediately set the radius to 1/35, which no, I don't have memorized yet in digits. And I need that for 4 or 5 of these things. Enter to invoke the last use command, enter to invoke the fillet command, enter to invoke the fillet command. And I think there's the last one. Enter to invoke the fillet command and round off that corner. This one is 3/8, so I'll hit enter to invoke the last command, type their pick radius to invoke the radius option, type 1/8, which is the same as 0.125. What happened? Double check here, 0.125, enter. Okay, I'm not quite used to the dynamic input yet. Now the radius is set to 1/8 of an inch. Click, click, rounds it a little more generous there. I believe that open area is our profile. Now, the elegant, proper, impressive way is to trim and shave off this and weld all these lines and arcs into a closed polyline with the join command. By the way, we can lose these 2 guidelines before you ask what they're still around for. An easier way, just in case you got double lines somewhere or 0 point lines that at the ends of lines or radii. An easier way is to crosshatch boundary. Now it'll take me a minute to find it. I still haven't used it on the 3D modeling workspace, so forgive me. I'm going to toggle back to drafting and annotation from introductory class. Drop down this cross-hatching icon on the draw panel and select the boundary icon on the tool flyout toolbar. We'll click boundary, we'll pick points, and we'll click in this open area. By the way, it's a wise idea to have your entire shape on your display before you pick an open area. Boom, there, the dotted line goes all the way around. Get the warm and fuzzy that you succeeded in placing a polyline all the way, a closed polyline all the way around. I'll hit enter to finish the closed polyline. Now getting this off is, you could probably click here and select the newest of the objects. But to be on the safe side, I'm going to click move and type L enter to get the latest thing created. Hit enter and move it to the side. Polar tracking, so I keep it the same distance above the center of the shaft. Okay, we'll click once on it, right click, pick properties, and yep, it's a polyline, and yep, it's closed. Closed polyline is one of the very, very few things that can be extruded and revolved. I can only think of 3. Anyway, we'll click escape to deselect. We got a perfect profile there, and we still maintain the axis of rotation. Toggling back to the 3D modeling workspace or ribbon, we'll drop down the extrude flyout toolbar, click revolve or type the word revolve and hit enter. Select it and hit enter. Oh, snap, anywhere on the axis and polar track right or left for a second point on the axis of rotation line. Dun, 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 dun. And there is our revolve pulley. Oh, wrong icon. I don't know why they put orbit on the first on the flyout instead of free orbit. I highly recommend free orbit. What is it? 3DFO is the type in. I'll click on the free orbit icon. We'll revolve it to get the warm and fuzzy that we succeeded. I just noticed I don't have the threaded hole for the set screw, but that's okay. You will leave it somewhere, hit escape or enter to lose the 3D free orbit. And we'll change the visual style to conceptual. And we'll launch the 3D free orbit again. Get the warm and fuzzy that we've succeeded in creating a solid model with the revolve command. By the way, save your file. This is going pretty fast, but save your file every 5 minutes, maybe. I forget what the automatic save is. It might only be 20. Anyway, it might be as long as 20. Anyway, we got the solid model done. That's half of the handout. Let me zoom out if I can remember how. There's the solid model. That's what we got. The handout had hidden instead of conceptual visual style to save ink probably. Now check it out. I cut out a quarter of it. You know, had I thought fast enough, I could have saved the profile and moved it out here and revolved it again at 320 degrees. But I didn't think fast enough. So I'm going to slice this vertically and horizontally, so it's into equal quarters, and then erase one of the 4 quarters. I may or may not think the union of the other 3 back together again. We'll see. Anyway, let's go back to the 2D wireframe. So I got a fairly good target at clicking on quadrants and later midpoints. Okay, let's remember which way's forward here. Okay, the opening of the pulley is on the right side. Let's go back to 3D model, the wireframe. Let's click slice, the sandwich looking icon, or type the word slice and hit enter. I want to slice this 3D solid we just created and hit enter. I'll slice it vertically with a cutting plane along that is parallel or is right on the XY plane. Notice 3 points is the default for the slice command. That's exactly what we want. I've never used these others. Well, it's maybe view. No, I think I see no reason to use the others. My advice is always use 3 point, and wisely picking your 3 points if you've got enough geometry in your drawing is just as good as these, with the exception of view. But anyway, what was I? Hit enter to select 3 points, or click on the 3 points option and pick 3 points that are on the XY plane. Well, the quadrants up here are on the 3D XY plane. A quadrant over any one of these top circular 3D objects, or the 2D wireframe lines, is a usable quadrant. Let's go down here. The third one cannot be on the same line as these two. So I can't just pick another quadrant in this series up here, because then all 3 of them will be in a line. I'll come down here and pick one of the quadrants. Let me zoom in to make sure I got a quadrant at the bottom. Not, yeah, I'm afraid, well, either way, I think any of them will work. I'll be on the safe side and pick one on the outer edge. I've sliced it. Now it asks which side do I want. Well, for now I want both. Enter. By the way, if I want both of them, I better save this for the viewport, and I'll union these two together to get a viewport that shows this on the handout. Where was I? Now I need to rotate it about the with a cutting plane about the ZX axis. Okay, I'm trying to cut it about the ZX axis. So I'll slice this pulley into 3/4. Hit enter, escape to lose the 3D free orbit. Launch the slice command again. Select both halves. Enter for good measure. Hit enter to immediately invoke the 3 points method. And let's pick 3 points that are on the XZ plane. That would be 2 of them over here. It's a midpoint. I guess these quadrants are midpoints now that I've got them into 180-degree arcs. I'll click a midpoint there, and a midpoint over here. Oh, that was risky. I almost endpoint O-snapped at the end of this axis. Let me go here to a midpoint of a curve. There, those 3 points are all on the XZ plane. It's asking me which side do I want to keep. I always hit enter to get them both. Now I can manually erase 1 quadrant, enter, go back to 3D orbit, revolve. I'll try to match the handout. I think that is going to come out when I invoke a hidden or conceptual visual style. If your instructor's picky, sometimes I leave the halves intact just to show how I develop the view. But if your instructor's picky, you might want to union them together. It's the 2 blue squares union together, or type the word union, select them both, hit enter. Lose this axis of revolution, and now you can develop viewports showing each of these 2 views. Oh, you might, again, for good measure, you might union all 3 of those pieces together. union, select all three of those pieces, enter. We roughly match the handout. Not perfectly, but hello. I hate it when that does that. All right, we'll cursor over. Very similar to these two views. So I don't think there's, I'll shut this video off. I think y'all are smart enough to click on layout, develop viewports, and window each of these in a separate viewport and possibly line them up by the center line of the axis. It's polite to make them the same scale. So I'll call this good enough. Catch you later. Bye. More end.